Hi, my Algebra 2 students. This is just a little overview and a couple sample problems off the review sheet for Unit 0. So this first top part of it, you're going to notice this is all the topics. So the first set of topics was all on the summer packet, which you are responsible for, and those will appear on the test coming up. And then the rest is what we covered since then. So factoring, the different types, greatest common factor, trinomial, difference of squares. But then it says seeing structure. That's the dummy variable ones. Factoring completely. And then solving absolute value equations algebraically as well as graphically. And that actually goes for solving any equation graphically. All right. There's a few that I figured would be worth looking at together. One is from the summer review section. And then I think the other two that I picked are from the more current stuff that we've done in class. So they are numbers 6, 18, and 27. I wanted to look at those ones together. Also, by the way, the last page of your packet is a graphing calculator reference sheet. So in case you need any assistance with all of that. All right. So I'm going to switch to another sheet of paper and I'm going to do those 3 examples from the review sheet. So number 6 says simplify, and you have the expression 3x squared y cubed raised to the second power, and then 2x cubed y squared raised to the third power, and then all of that over 2xy, that quantity squared. Now we will actually do a unit later in the year all about exponents, so you will see this topic again with more emphasis. But for right now, there's rules at the top of your review sheet. So reference these if needed. They're the rules that are boxed in right here. And a lot of them are the idea of what happens when you have like a power raised to a power. So when I'm saying I'm going to square this whole thing, I have to square the number. So 3 squared becomes 9. And then power raised to a power, you multiply. So a power of 2 raised to another power of 2 becomes x to the 4th. Y cubed, that quantity squared, becomes y to the 6th. All right, over here, you're cubing everything. So 2 cubed is 8. And then x cubed becomes x to the 9th because you multiply. And then 2 times 3, that becomes y to the 6th. And then on the bottom, square everything. So 2 squared is 4. X squared is literally x squared. And then that's y squared. From here, multiply together what you can. There's another rule. When you're multiplying the bases, you add the exponents. So 9 times 8 would just be 72. X to the 4th times x to the 9th would give you x to the 13th power. Y to the 6th, y to the 6th gives me y to the 12th. And then all over 4x squared, y squared. Finally, you get to use another rule. Now you're dividing. So 72 divided by 4. I feel like I'm having a brain fart here. So let's see here. 72 divided by 4 is 18. Good thing I checked that. And then x to the 13th divided by x squared, you subtract the exponents. So that would be x to the 11th, y to the 12th power divided by y squared, subtract, you get y to the 10th. All right. All the answers will be up on the Google Classroom fairly soon if they're not there yet, so that you can check your answers as you go. All right. The other two that I said I wanted to look at were number 18. So 18, the directions are to factor. So we've got 16 minus the quantity x plus y squared. And then the other question is 27. We'll get to that in a moment. So keep in mind, if the question said multiply, I would square this thing out using box multiplication, but it says factor. So in that case, this is a dummy variable. I might say let a equal the quantity x plus y, and then I would rewrite it. So this would be 16 just minus a squared. So this is difference of perfect squares. So take the square root of each. Square root of this is 4. Square root of that would be a. 1 plus 1 minus. And now sub back in. So in place of the a, I'm going to put in x plus y. In place of the a here, I'm going to put in x plus y. Now where you can lose the parentheses, if I'm adding everything in here, the parentheses aren't needed. But if I'm subtracting and I want to drop the parentheses, I need to distribute that minus sign through. So it becomes minus x minus y, like that. Could you just keep the parentheses? Sure. But if it was a multiple choice question, you'd want to recognize that these two are equivalent answers. All right, last question that we're going to do as a little warm up here is number 27. And the reason being that I feel like every year people ask me, how the heck am I supposed to do this question? So let me tell you. We got absolute value of 3y minus 5, and then minus the absolute value of y minus 2, and then equals negative y cubed plus 3y squared plus 1. Now the directions say solve and round your answers to the nearest tenth. So right there is kind of a hint that the answers aren't going to come out nice. That doesn't mean you have to pick up a calculator, but when I actually look at the problem, yeah, you have to pick up a calculator. We have not talked about how to solve anything cubic, honestly, unless it's nice, pretty, and factorable. But even then, we've only factored, we haven't solved. So our default then, y1, y2, and graph it. That's how I want you to approach this question, right? So I'm actually not going to fully finish it. I believe there are 3 solutions as a little hint, but I want you to graph the 2, and then you're looking for the intersection points. So that's the second trace intersect. So I just wanted to at least get you started on it, and then we can talk about it in class. All right, guys, thanks for watching.